Okay, so what we're going to do now is we're going to take a look at some of the mathematical library functions that are built into cmath. Now these are more functions. Functions aren't going to go away. They're just going to be these really powerful modular components that help us take care of tasks. Because if we had to keep reprogramming these same things over and over and over again every single time we wanted to use them, it's a little too repetitive. We don't want to do that. So people have created these functions that we can use for the time being. Think of them as the magic black box until we cover functions. Everything will make much more sense as soon as we cross that. And we'll actually be writing our own. So let's go ahead and include a new library that we're talking about here, which is cmath. cmath. There we go. Now, what does cmath allow us to do? cmath allows us to include all these different types of mathematical computations that we're used to, and that could be something as simple as representing exponents, square root, absolute value, cosine, log sign, all of those different things that we're maybe exposed to in some of our mathematical topic classes. And we'll go ahead and take a look at those. So what I'm going to do is I'm going to open up an image that I'm going to put in front of you. And what we want to do is we want to see if we can represent this 2 to the 4th power here. So if we were to do that without the use of any functions, and let's make a double, and we'll call it number, pretty generic, and let's set number equal to let's go ahead and set it equal to 2. Now if we want to represent 2 to the 4th here, this is what could happen if we needed to do that. Number equals number times number. Okay, so we have 2 to the 2nd here times number. We have 2 to the 3rd times number. There we go. Okay, now that's very clunky. Wouldn't you say that that's very clunky? Again, so this is number is assigned with number times number here. This is number to the 2nd. This is number to the 3rd. This is number to the 4th. So what we can do is we can employ this function here, and we can stick inside of it the base and exponent as function arguments, and get it equivalent to an expression. Because what if we said that, okay, I want 2 to the 4th here, and on the next one I want 2 to the 5th? Well, you'd have to write an entirely new line. So what if we did this instead? What if I asked the user, and I said, user, enter in a base. And let's change this to actually represent. We're gonna make base an exponent. So we'll have C in the base. We're gonna have C out. User enter in the power of exponent value. Right, and then we're going to C in exponent. Alright, and now here comes that function. So what is that function again? Well, the function is called pow. Pow belongs to the cmath library, and if we want to assign something with the return of this function, this is how this works. This is kind of like the magic black box we said. So we have pow is the name of that function. We need to call it by its name, and then we need to send the data in like a little care package along with it. Now, what is the data that we're sending? They're doubles. Okay, and that's defined in the manual on how to use the cmath library function pow. So the chart is on Blackboard, and there's also a chart in your textbook as well. And you can always look up the C++ manuals around the web as well if you're ever unsure on what data types the function requires. In this case here, doubles, that's perfectly fine. There's more than one argument. Okay, there's more than one argument, so they're separated by a comma. Okay, so 2 arguments in this function, and when this function returns, it turns into the value of what the completion is of the function. So in this case here, it would be the value of 2 to the 4th. Okay. So we're going to go ahead and stick the pow function in here. We're going to say pow, and then let's give it the argument list. So here come the argument parameters. 2.0, but wait, didn't we make variables for this? Yeah, that's exactly right. We made variables. So let's go ahead and stick those in here as the arguments. And we can absolutely do that. Now this makes it completely dynamic, and because it's dynamic, we now can see exactly what any base raised to the power of with this this function here, the way that we have it configured. It's really powerful. I'm going to make one more double, and I'm going to call it result. And I'm going to set result, because the only way to see this is to put it in a cout statement. I didn't even spell result right. I didn't do it again. This keyboard is killing me, you guys. I really like it, but I really am starting to hate it. Okay, here we go. Result is assigned with the return of this here, and then we can go ahead and we can see out the result, and it's stored, so if we want to do something else with it, we can. We could as easy as well just said cout statement here and then cout this this return here, but it doesn't store it to do anything else. Should you have to create a variable every single time for this? No, not at all. I'm just doing this ahead of time because I may need to use this value later on in my code. So let's see. So let's go ahead and run this. Okay, we're ready to run here. Enter in a base, and let's say 5. Exponent value 2. We get 25. Perfect. So we know that that's ready to go here. And the other example that we had was 2 to the 4th. So let's put that in. 2 to the 4th. We have 16. Cool. So this works perfect. Let's go ahead and pull in another function from that library as well. And now you'll see why I insisted on making the third variable here results, because I'm going to use this. So let's use the square root. Let's use the square root function. And the square root function is only going to take one single argument. So whereas pow took 2 arguments, I need the base and the exponent in order to figure it out. Square root only needs 1. So we're only going to send 1 argument in there. You can send more than 1 component to an argument, but the arguments have to be 1. So if I had to send 2 things in here, say if I had like 5 plus 5 here, it would need to be wrapped inside. It would need to be wrapped inside of parentheses, so that when it reads it as an argument, it reads it as 1 argument, not 2. Okay? I just want to make that distinction very clear. Alright, so now here I'm going to take result, and I'm going to put result inside of this square root function. I'm just going to put a cout statement in front of this. I'm going to put cout, and let's put some text, is the square root of the exponent and base. Yeah, sure, that's fine. Okay, so we're going to take 5, we're going to raise that to the power of 2, 25, and then 5 is the square root of the exponent and base. Press any key to continue. Perfect. So that's just 2 of the cmath library functions that I wanted to show you. Just kind of wanted to show you them in action. The other functions work exactly like that, and there's some examples up there so that you guys can follow along. Check these out. I want to kind of stimulate your thought to fill in the gaps for the rest of the portions. Also take a look at the assignments that are up. And the assignments are a little bit more complex. They're supposed to be a little bit more challenging and have you take this information to the next level. So if you have any questions, please use discussion board and we'll see if we can hammer them out. Thanks guys. Look forward to seeing your assignments.